In this demonstration of detailed design, we'll define some global specifications, we'll generate initial layer shapes with zone-to-layer analysis, we'll make layer changes using local specifications, and we'll use multiply design in combination with zone-based design for pad-ups and final layer shapes. Zone-based design is a specification-driven design process that begins with laminate specifications or groupings of material specifications applied to the zones themselves. Additional specifications also help with the automation of the design. Here, this particular laminate specification has 35 material specifications, again applied to a particular region of this part. Stagger profiles are defined at the laminate level and are controlling the cross-sectional profile that drop off from thicker to thinner regions. We'll define our first offset spec, which controls the spacing behavior of each edge of ply throughout the design. We'll then go back to zones and we'll run zone-to-layer analysis algorithm, which utilizes the zones in the specifications to create layers, which are an engineering definition of the plies and their boundaries. These are initially created, again, based on the global specifications, but also have building blocks that make the creation of other local specifications and local changes easy. Here, zone transitions, which are the basis for boundaries, are being modified, and a different drop-off type is being applied, and you'll see that it immediately has an effect on the layer boundaries. Transition adjacency vertices control corner behavior. Here we're going to change one vertex to have a chamfer. Again, it will have an immediate impact on the layer boundaries themselves. So as you can see, layer results are based on global and local specifications with little to no geometry creation, making changes simple. Hybrid design processes like combining zone and multiply-based design make the design process much easier. The following example shows the advantages. We have 4 additional pad-up fastener regions that are required, and multiply uses an independent overlay zone that can be created on top of traditional zones, eliminating the need to redefine the traditional ones. So here we're applying a laminate specification to these overlay zones in order to create the plies for those pad-up regions. We're running zone-to-layer analysis again. And using filtering called active laminate allows me to then focus or view just the zone transitions and the layers that were created for those pad-ups. So here we're looking at those zone transitions for the pad-ups and just the layers for the pad-ups. All the layers, however, can be viewed together. And interleaving of all of the layers, the ones that were created with the multiply design and traditional design, can actually be easily accomplished in what's called the Composite Sequence Manager. This utility allows me to drag and drop specific plies and change the order of stack-up. So here I can just view the entire stack-up. If I like it, that's great. If I need to make changes, I can just grab a ply and drag and drop